Welcome to the final video of this week. I'd like to share with you in this video how LLMs are starting to be able to use tools and then also discuss a cutting-edge topic of agents, which is where we let LLMs try to decide for themselves what action they want to take next. Let's take a look. In the earlier example of a food order-taking chatbot, we saw that if you were to say, "Send me a burger," the bot may reply, "Okay, is on the way." In order for a chatbot to enter the order and send it to you, this is what actually is happening behind the scenes. The LLM can't just say, "Okay, is on its way," because it needs to take some action to actually send the burger to you. And so an LLM might output this response: order burger for user 9876 to send to this address, and then also say the user message is to say, "Okay, is on its way." An LLM that's been fine-tuned to output text like this will be able to generate an order, which in this case would trigger a software application that passes to the restaurant ordering system a request to deliver a burger to this user at that address. And what is shown to the user is not the full LLM output. The full LLM output is all 4 lines of text here, but only the final line, "Okay, is on its way," is what gets sent to the user as the response. So this is an example of tool use by an LLM where the text the LLM outputs can trigger calling a software system to place a restaurant order. Now, placing an incorrect order can be a costly mistake, so perhaps a better user interface would be, before finalizing the order, to pop up a verification dialog to let the user confirm yes or no if you've got the order right before charging the credit card and sending it to them. And clearly, given that LLM's outputs are not completely reliable for any safety critical or mission critical action, it would be a good idea to let a user confirm that that's the right action before letting the LLM trigger some potentially costly mistake by itself. In addition to tools for taking actions, tools can also be used for reasoning. For example, if you were to prompt an LLM, "How much will I have after 8 years if I deposit $100 in the bank account that pays 5% interest?" An LLM might generate an answer like this, which sounds plausible, but the number $147.04 is not actually the right answer. It turns out LLMs, having learned to predict the next word, or maybe even instruction tuned, are not great at precise math. And just as you or I might use a calculator to calculate the right answer to a problem like this, we can also give the LLM a calculator tool to help it get the right answer. So rather than having the LLM output the answer directly, if the LLM were to output this, after compounding and so on, you would have calculator 100 times 1.05, that's 5% interest rate compounded to the power of 8. This can be interpreted as a command to call an external calculator program to explicitly compute the right answer, which turns out to be $147.74, and plug that back into the text to give the user the correct dollar figure. So by giving LLMs the ability to call tools in its output, we can significantly extend the reasoning or the action-taking capabilities of LLMs. Tool use today is an important part of many LLM applications. And of course, designers of these applications should be careful to make sure that tools aren't triggered in a way that causes harm or causes irreversible damage. Going beyond tools into a more experimental area, AI researchers have been examining agents, which go beyond triggering a tool to carry out a single action, but is exploring whether LLMs can choose and carry out complex sequences of actions. There's a lot of excitement and research on agents, but this is at the cutting edge of AI research. It is not yet mature enough to count on for most important applications, but I want to share with you what many in the AI community are excited about. If you would ask an agent that's built on top of an LLM, "Help me research Better Burger's top competitors," then an agent might use an LLM as a reasoning engine to figure out what are the steps it needs to carry out to do your task of researching Better Burger's competitors. And this reasoning engine, the LLM, might decide it needs to search for the list of the top competitors, then visit the website of each competitor, and finally for each competitor, write a summary based on the homepage content. And then perhaps by making a sequence of calls to this reasoning engine, it may figure out that to search the top competitors, it has to trigger a tool to call a web search engine on the query Better Burger's competitors. And then after that, it may visit the websites of some of the top competitors to download their home pages. And then additionally, call an LM yet again to summarize the text that it found on the website. On the internet, there have been some nice demos of agents, but this technology is not really ready for prime time yet. But perhaps in the future, as researchers make it better and better, it'll become more useful. And I think that would be an exciting future if LMs as a reasoning engine can help decide what's the sequence of steps to take, safely and responsibly, of course, to help a user carry out the task. Thank you and congrats on making it to the very end of week 2, with just one more week to go in this course. Next week, we'll look at how generative AI is affecting companies, including how you might be able to come up with generative AI use cases for your business, as well as look at how generative AI is affecting society and its impact on jobs. I look forward to seeing you next week.